Okay, so we're going to power through cylindrical and spherical coordinates. Hold on. Okay, so flashback to polar coordinates. Remember polar coordinates? We just did those in January, correct?
Yeah.
Okay. Is it? Oh, sure. I'm so sorry. So polar coordinates, x equals r cosine theta, y equals r sine theta. If we want to go from polar to Cartesian, Cartesian to polar, we know that r is radical x squared plus y squared, and theta is the inverse tangent of y over x. Okay, this is what you did in pre-calculus. We reviewed it again in January, and we did some calculus with polar area, polar derivatives. What did you say?
We're going to have to remember that eventually.
Yeah, like next week. We're going to do a review project, so it'll be good. Okay, so cylindrical coordinates are essentially polar coordinates with the z-axis, okay? So what we have is we have the coordinate r theta z, where r theta is like the r comma theta that we worked with in 2 dimensions in January. Now we're just tacking on literally the same z as we've been talking about the past week and a half. So we move in a cylindrical motion, where we move in the xy plane about the circle of the polar coordinate system, and then we travel up or down vertically along the z-axis.
Wouldn't the theta make it sound better?
It'd be like
Roz. No, it's theta.
It makes
Jeez,
it
like
easy.
I think I missed something.
I think that one was hard. This one two's actually easy with that one. This is the same one.
Okay, so really cylindrical coordinates, there's really not a lot to adjust to because going from xy to r theta and vice versa is going to be the same as it was in 2 dimensions. The only thing that's different is there's a z, and z doesn't change. So if we want to go from rectangular to cylindrical coordinates, we do the same thing we did before. X squared plus y squared equals r squared, and the tangent of theta equals y over x. In our 3rd dimension, z gets to stay a z. Right?
I love that.
This is calc stuff.
Z equals
You
z.
don't learn this.
And from cylindrical to rectangular, x equals r cosine theta, y equals r sine theta, and z equals z.
But you write it the other way.
Yes, we do. You're in rare form today.
Like cylindrical Z and the bar lower on the rectangular Z. That way you know which one's which.
Yes, yes. Some subscript notation. Okay. Okay, so write down this coordinate. Okay, so if this is x, y, z, then we need to take 2 radical 2 squared plus negative 2 radical 2 squared equals r squared.
R equals 4.
Hi. Thank you. Okay. Tangent theta equals y over x would be negative 1, right? But we also need to think about in the xy plane, the quadrant in which this would fall. So we know that we have a 45-degree reference angle, but what would our actual angle be?
315.
Okay, because we need to make sure we are going right and then down in the xy plane. So our cylindrical coordinate would be
Don't forget the z.
r, you know what?
Z.
Oh, sorry. What is z?
Yeah, z equals 4.
Okay, thank you. 4, 5 pi over 4, and 4.
Maybe 7.
Yep, it would be 7. I just processed that.
Why did we write 315?
I'm in kind of degree mode from pre-calc. Like I forgot to change my mode back to radian mode for this class. So, sorry. I kind of feel like one. But you know when you're like kind of on the roll with like a certain notation and then more square. Okay, let's go the other way. Nope, just kidding. Not the other way. This is another one. Your turn, without me. You do it. Be careful of that Z.
Oh yeah. Oh, you getcha.
Check with the neighbor.
I have like I'm so
Yeah.
paranoid about that movie because for a while I had opening night tickets, and then I realized that one of the people I was going to so I went so long.
And you didn't ask me if I wanted to go.
Sorry, I mean I made like humongous.
But I could have bought them from you.
So now I'm seeing it like 4 days later, but I'm paranoid that people are gonna like spoil it.
When does it even come out?
April.
April what? Like the 6th? Man, that's like really planning it.
It's almost April.
It is almost April, isn't it? Dang
April
it.
26th.
Oh.
See, that's like a month away. Exactly, because it's the 26th
But it's
today.
gonna sell out quickly, so you want to buy earlier so you can get good seats.
I just feel like that's crazy. It's very crazy.
See, there's no other movie. Like they said.
Okay, we're focused. What is this cylindrical coordinate?
2. 4, 5.
Yeah, that's it. It's just 2. I don't know. I don't know if this is correct. Is it negative radical 3?
Okay, let's go the other way. Please write down this cylindrical coordinate. Radical 4 would be fine.
Yeah, and then there's just like that different kinds of.
Okay. This is the easy transition, I think. You don't have to think too hard. X equals 4 cosine theta. Y equals 4 sine theta. So our coordinate would be 0, 4, and then z is -2. Okay. Going from rectangular to cylindrical, we have to think about the quadrant in order to get the correct angle. But here we just plug and chug all the way through.
So I said it to my dad last night. He was like, "What does plug and chug mean?"
And then you chug. All right. Oh, no, this isn't the example. This is the example. We are going to convert some equations. We're going to convert equations from one form to the other. So this is obviously a cylindrical equation. And we want to convert it to rectangular. So what of the 4 things I had you write down in the very beginning, which one of those could help us figure out what this is? You had 4 conversions.
Z equals Z.
5 conversions. Thank you.
Tangent of theta equals y over x.
Okay, we know that the tangent of theta equals y over x. Okay, so we have the y and the x, there's the theta. Well, if theta is pi over 4, then the tangent of pi over 4 is equaling y over x. And what is the tangent of pi over 4?
1.
Okay, so y over x equals 1, or y equals x. Okay, in 2 dimensions, this would be a line. However, in 3 dimensions, this represents the plane. Did you just make a plane noise? Y equals x.
I am speaking.
Sorry, it was just.
It's okay. It just,
I was like, "Oh, I know what that is."
I was looking for the answer, and you made a noise instead of the word, and I just.
But was it incorrect?
No, that's
And why
yeah, instead of snowboarding plan, I'm gonna
It's like
I'm gonna take a recording of my voice, but like tape it to a flash drive. Put it on a flash drive. Tape the flash drive.
That seems like a lot of work. Okay, write this one down.
Hey, Z equals Z.
We got that part down.
But how do we get rid of this r squared?
Plug in x squared.
We know r squared is x squared plus y squared, and x squared plus y squared plus z squared equals 9 would represent a sphere of radius 3.
That's
Okay. One more. X squared equals what? We're going to go to cylindrical. Now, this transition, if you have an x squared plus y squared, throw in an r squared. Otherwise, we know that x equals r cosine theta and y equals r sine theta. So you don't have to be as on the lookout as you do going the other direction. So what we have is r squared cosine squared theta equals r sine theta. And I do ask that if you can, try to solve for r. It looks like we would be able to here, right? We could divide this r over to where there's only one r. And we could divide this cosine squared over to where we have sine theta divided by cosine squared theta. So I would accept sine theta times secant squared theta. I would accept tangent times secant. Okay. Why?
Because secant tangent is the thing, like the derivative.
It is, yes.
Yeah.
Alphabetical.
It's not real math.
It's like $10.
Is there a noun for describing something that is in alphabetical?
It's alphabetized.
Something that
It's alphabetical.
the the quality of being in alphabetical, like alphabeticalness.
Alphabetize.
Okay.
Anyway.
So I want to talk about a few things. Don't write these down.
You know,
Okay. So a paraboloid would look like z equals r squared or z equals x squared. Okay. I'm not really concerned about that. A right circular cylinder is going to be r equals a value. So like r equals 5. In 2 dimensions, that was just a circle. Well, now in 3 dimensions, it would be a cylinder. So if r equals a number, we have a cylinder. Okay. A sphere, we already looked at one like that. Whoops. R squared plus z squared equals a number squared. Okay. That would be a sphere. A right circular cone with vertex at the origin would have the equation z equals mr, where m is like a slope. A helix has the following equations: r equals r and z equals a number a times theta.
Yeah.
Just a theta. Okay. So examples. This would be r equals 5 is a cylinder.
Yeah. Oh no.
Well, I was trying to figure out the order of the y and the l because it was.
Clint.
Clinder.
Yes.
It's a cylinder.
Just draw a cylinder.
it's one of those things.
It should not be that difficult to spell.
You identified it.
A radius 5. What is this?
Spheres.
A radius 10. And what is this?
Cone.
A cone.
With a slope of 1.
Okay, yes. And since z equals r, the radius and the height would be the same. All right, are you ready for some spherical coordinates?
What happens if you have a sphere made of?
Cylindrical coordinates seem kind of boring, right? I mean, it's like 3-dimensional polar coordinates. Where's the fun in them?
It's literally just polar coordinates, and now there's a Z. I didn't know we were graphing igloos.
No, get out of here with the P. It's not rho.
That is a row.
That is a row.
Row of theta 5.
Okay, so spherical coordinates are a system of coordinates that are natural for describing positions on a sphere. So it's basically rotations from each axis.
So it's
Okay,
like alpha, beta,
And then
gamma.
you move out,
The radius.
okay?
What happened? What did we do?
I don't know. What did happen?
What is going on?
Let's do this.
This is. I don't like this.
Okay.
Ooh.
Rho is the distance between P and the origin. Theta is the same theta from cylindrical coordinates. So theta is how far we rotate in the xy plane, is maybe how I would describe it if I were you. Okay. So we're going to rotate in the xy plane, theta. We are going to rotate from the xy plane up to the angle, phi is the angle between the positive z-axis and our coordinate. And then we're going to move out, like I said, that row. Whether you say phi or phi
Oh.
Sideways theta.
And then phi is just
the fact that you said that in unison. Sometimes it's pronounced phi, sometimes it's pronounced phi. I'm not going to be picky about it. I don't really know the rules of when it should be pronounced, which pronunciation. But it is the angle between the z-axis, the positive z-axis, and our coordinate. It's always going to be between 0 and pi, okay, because we're talking about the positive z-axis. We're not going to rotate more than pi, okay? So how do we find all these things?
You do. It's not.
Okay. So this is kind of nice because instead of in cylindrical coordinates, we're still rotating and moving out, but instead of counting up, sometimes it's easier to rotate and count out along a radius, okay, which is essentially what we're doing with rho. So it makes certain calculations easier. Now, we are talking about kind of our polar coordinates here, but then we're also talking about this angle right here. So we have a lot of trig happening right now. You ready? Go ahead and write these down.
Oh man, Z
I'm
doesn't
gonna
equal
lose
Z
track
anymore.
of variables.
Z does not equal Z anymore. So you see the r cosine theta and the r sine theta with the x and the y, but sine phi is also thrown in there to account for the rotation from the z-axis. And then z is phi cosine, rho cosine phi. I'm sorry. Rectangular to spherical, we still have our tangent of theta equals x over y over x, We still have that the rho is, this is the distance from 0, so it's the distance formula. And then phi, we're talking about that. Once you write this down, I'll go back to the picture and point out a couple of things so you can appreciate that right there.
I think these things single-handedly have the worst letters I've ever seen.
What? They have the most what?
Letters.
Letters? Symbols?
Things that aren't numbers.
Isn't that just C over rho?
That entire.
Phi equals arc cosine of C over rho.
Yeah. Can I go back to my picture now?
Yes.
12 seconds.
I only got to 4 from my countdown. Okay.
Oh,
So-
I thought you only counted 4 up.
No.
Definitely a hot 7 or 8 seconds.
Okay. So when we're talking about so like this coordinate here, like if I highlight the triangle here, okay, here is Z and here is rho, and so we have the arc cosine of Z over rho. Do you see how that would be phi? Okay. When we're going the other way, okay, we have to account for, we have the theta in the xy plane. Oh, it's hard to make that right triangle stick out, isn't it? This is the right triangle, but you can't see it. That's the right triangle right there for the x and the y. Are there any questions about the formulas? Is that the
No, it's the one with
No.
the intersection of x and y lines.
this guy?
Yeah,
I'm gonna say I put it there and then that didn't look right.
that's right.
Yeah, always back to the x-axis.
Yeah.
Okay.
It was 3 dimensions, so you just draw a right triangle.
It's just kind of crazy, isn't it? All right. More than likely, we will need to do a few examples tomorrow with the equations. We'll at least do the coordinates here. I want to convert the coordinate 1, 1, 1 to spherical coordinates. So rho is the square root of x squared plus y squared plus z squared. What's rho?
Radical 3.
Okay.
That's where I'm at.
The tangent of theta is
Equal to
1. 1 over 1. So theta is
1. Pi over 4.
pi over 4. The cosine of phi is 1 over radical 3.
That's the arc cosine, wouldn't it be?
Oh, yeah, sorry. I wrote it like that, but it's the same thing as the arc cosine of 1 over radical 3. So our coordinate is radical 3, comma 1, comma whatever the inverse cosine of 1 over radical 3 is. So you can put it in your calculator if you want to give me the radians.
Wait, why did you put in 1 instead of pi over 4?
Why did I put 1? We have pi over 4 written right there. Why didn't you stop me before? Sorry. I was looking at this right here and I just wrote 1. Okay,
Doesn't seem too bad.
let's go the other way. Pi over 4, 3 pi over 4. So our x is rho sine phi cosine theta. And our y, I'm just going to write them together, is 5 sine phi sine theta. So remember we have the same like r cosine theta, r sine theta, but then we have to throw the sine of phi in there. Okay? So what? We have 5 radical 2 over 2, radical 2 over 2 to give us
5 halves.
and y would have to equal
All
Also 5 halves. Yep, that's not very exciting. And then z is not z. It is rho times the cosine of phi. So we have negative 5 radical 2 over 2 for that one. So our spherical coordinate is 5 halves, negative 5 radical 2 over 2.
H. It's so satisfying until you get to Z.
So far, so good? Let's do this one. Okay, this will take us to the bell, and then we'll start class with one example tomorrow, and the rest of the time will be yours to work. If you want to start the homework tonight, you can, but we'll literally have 40 minutes tomorrow. Okay? So, we need to change this to spherical. We know that x is the same thing as rho sine phi cosine theta. And we know that y is the same thing as rho sine phi sine theta. And we know that z is the same as rho cosine phi. So now it's a matter of working with our good old-fashioned identities. Okay?
Could we not leave it like that?
Nope.
You can divide everything by p squared.
Okay.
Rho squared.
Okay. So the row squareds can be divided out. And what's in common on the left side?
Sine phi squared.
Which means left over is, wow, cosine squared theta plus sine squared theta. Okay.
So 1 equals tangent squared phi.
Right. So sine squared phi equals cosine squared phi. Or, like you said, tangent squared equals 1. Well, where does this happen at? Pi over 4 or 3 pi over 4. We have a double cone.
Wait. How does 3 pi over 4 equal 1?
That
Oh, that's because it's the
'cause it-
tangent squared.
because it's positive or negative.
Because when you square the tangent, it always
And 5 pi over 4 is going to give you the same line as pi over 4, so we don't need to worry about that.
This is
Why are we happy to have a double cone?
All right, so one more example tomorrow and then work time. I'll play soothing music. Or just music.
Smooth jazz.
It's like only